our studio. Today we're going to discover together the mysterious universe of nanoparticles. And to do so, we're fortunate to have as our guest Pierre, a nanotechnology specialist. So Pierre, what is a nanoparticle?
Well, it's a particle that's 1 billion times smaller than we are. The size of a nanoparticle compared to an orange is like the size of an orange compared to the planet Earth. Nanoparticles are extremely fine, but they're still 10 to 1,000 times bigger than a molecule of oxygen, for example.
And where are these nanoparticles found?
They've always been found all around us, as ultrafine dust in the air, for instance.
Really? Let's just double-check that with our special correspondent, Nano, who's now on location in the ambient air.
Yes, Kathleen, as you can see, in the air, there's a very large number of nanoparticles continually moving about. They keep bumping into each other, binding together, and reforming. The number is constantly changing, and when combustion takes place, watch! The number can increase 100 to 1,000 times.
Amazing! But Pierre, what is actually new about this?
In the past few years, we've learned how to produce different types of nanoparticles, which can be used to develop nanomaterials that sometimes offer very interesting properties. The question today is whether these nanoparticles are a hazard to health and the environment.
Right, but first of all, what can these nanomaterials be used for?
Well, they can be used in several areas: transportation, environment, healthcare, new energies, buildings, and so on.
Interesting. But for now, let's get back to Nano in a laboratory to see how things actually work in the field. Nano, tell us, for instance, can these nanoparticles really be controlled?
Well, Kathleen, it all depends on what state the particles are in. In the powder state, they can easily be dispersed by air movement, so precautions must be taken in handling them. Here, however, as you can see, they're quietly staying put in the liquid. They're much easier to contain. And in a solid nanomaterial, they're very well integrated within the structure.
Thanks so much, Nano, for your valuable report. So, Pierre, it would appear that the particles are firmly attached inside the materials. Is that right?
That is the question. Research is underway to try to determine for which materials and under what conditions nanoparticles could break away and spread into the environment.
Thank you, Pierre, for your explanations. In the next episode, we'll take a closer look at the applications of nanomaterials. Thank you for tuning in, and see you soon.